Hello everyone. In this video, we are going to talk about how to write API conversions for Kubernetes CRD. Throughout this video, we'll cover several topics like what problem do API conversion exactly solve. We'll also demonstrate the use of conversion gen tool and briefly give an introduction about the concepts that we extensively use during API conversions like hub and scope. And at last, we'll give a demonstration where we'll show you how you can write the API conversions for converting between different APIs. So let me introduce myself. I am Shivani Singhal, MTS3 at VMware, and I am a contributor to Cluster API Lifecycle Provider for AWS.
I am Madhur Agarwal, working at VMware, and I am a member of Kubernetes 6, working in cluster lifecycle.
Before understanding how to write conversions, let's first understand what problem do API conversions solve.
We know that Kubernetes clusters have multiple APIs, and each API starts with the alpha version and then gradually evolves over time. And as APIs evolve, the cluster needs to update to the latest version. The clients of the API server, like controllers and users, can also upgrade to the new versions, but it is not necessary that all the clients might upgrade to the new version. So, if the cluster has upgraded to the latest version, then what will happen to the clients who are querying the API server and the clients are having the old version?
So to solve this issue, we have API conversions for rescue. Let's understand this with an example. Suppose we have a Kubernetes server that stores data in etcd with latest version, that is V2. A client, Daniel, who is on V2 version, tries to write a test object on the server. Then API server stores the test object in etcd with version V2. Then another client, Bob, which is on V1 version, tries to fetch the same test object. But how will the API server convert the test object from version V2 in etcd to the version V1 requested by the client? So to solve this, we will write API conversions. These functions converts the etcd data to the requested version. Another use case is when client on older version updates data in etcd which is on new version. This scenario might lead to a case where we can lose the data.
Didn't get how data can be lost? Let's try to understand it with an example. So I'll try to explain the example first. So we have an application, Kubernetes application, which will have a CRD called registration. This CRD represents the vaccination of an individual. And we have a V1 API of our registration, which is containing the registration details of the person, like name, verified ID, and registration date. Later, multiple vaccines came in the market, so we updated our version to V2, which added a new field called vaccination name. And after that, we found that one person can be vaccinated with multiple vaccines and multiple times. So we added a new V3 API, which has a list of vaccination details. So we will assume for this example that the storage version of our etcd is V3.
So now we will demonstrate a case where a client tries to create an object of V3 version and stored it in etcd in V3 form. Then another client tries to fetch the same data in V1 version, update it and store it back into etcd. So we'll check due to the schema difference between V1 and V3 APIs, is there any data loss? But before jumping to code, I will quickly walk you through about our project's folder structure. So KubeVaccine is a KubeBuilder project following the standard KubeBuilder directory structure. We have API config controller packages. Under API package, we have defined our V1, V2, V3 APIs. So now let's start and apply a sample of V3 version. So here, if you go to sample, we have this COVID V3 registration YAML. So we will apply it and create an object of V3 version. So we can see our registration sample V3 example is created. So if you see it in JSON, you can see the spec. And the spec we have name, vaccine details and verified ID. Let's fetch the same object in V1 version. And store it in another YAML file. So if you see the V1 conversion of our V3 example, you can see in the spec we have name and verify ID, and our API version is V1. So let's try to update it. In the name field, we can add single and let's save it. So now we will apply this YAML and see our V3 object has been configured. So if you try to fetch this object again in V1 version, you will see it's same as what we have just created. The spec name is updated. Now let's see what happens if we try to access this object in V3 version. So we'll check is there any data loss or not. So we can see the spec. Here we don't have the vaccine detail, but if you look at the previous example that we originally applied, we had the vaccine detail. So this conversion and updation leads to a data loss.
Now we saw that data was lost while conversion from V3 to V1 and back to V3. So the data was lost while conversion from V3 to V1 initially because V1 is missing the field vaccination details which is present in V3. So when we convert the data from V3 to V1, all the common fields are copied but vaccination details is lost. And when we convert back to V3, we see that the final V3 has lost information as compared to the initial V3. So how can we solve this problem? So this problem can be solved using annotations. So annotation is nothing but a key value pair which is stored inside an object. So as you can see in our middle slide that we have annotations and we have stored the key value pair. So we solve our problem of data loss by storing the entire V3 object as in the annotations of V1. So basically you can see here that we have added an annotation conversion data where entire V3 object would be present. Now when we will convert from V1 to V3, we can refer this annotation and fill the vaccine details, and this way we won't lose the data. So this logic of storing data in annotations and restoring data from annotations would be a part of conversions. So we now sort of understand the logic of retaining data and converting from one version to another. But let's say if there are multiple versions, then do we have to write this logic for each pair of versions?
No, we will use Hubspoke model for this. Let's try to understand this with the help of diagram. If you see on the left hand side, we have several blue dots and each dot represents one API version. And a line connecting these dots represent a function that we use to convert from one version to another. So there are a lot of lines which represent we have to write lot of conversion function to convert between pair of API versions. So to solve this, we move to the right hand side and choose any one version as a hub and all other versions as our spoke. So in our example, we choose V3 as a hub and V1 and V2 as a spoke. So in this model, we will write conversions between the hub and all spokes. So in this way, let's suppose we want to convert from V1 to V2. So we'll first use conversion from V1 to V3 and then from V3 to V2. Here we can clearly see that in this model, we reduces the number of conversion functions. So now let's write the conversion for our example. But before that, is there any tool that we can use to write the conversions?
Yes, there is a tool called conversion gen which can be used to write conversion functions automatically for us. So now we will use conversion gen to write conversions for our project. Before doing that, we need to specify the hub. So in our project, we have assumed V3 as the hub. So we have added a method hub in conversion.go in V3. And for the spokes, that is V1 and V2, we have added a file called doc.go which contains a conversion gen tag and the hub. So this conversion gen tag signifies to conversion gen that it has to write conversions from V1 to V3 and vice versa. Similarly, we have added this for V2. So conversion gen will write conversion functions for conversions between V2 and V3. Now we will run the conversion gen tool. So as you can see, this is the conversion gen command, which contains input directories as V1 and V2. So conversion gen will scan these packages for these tags and write conversions for us in an output file called zzgenerated.conversion. So this will take a few minutes. Okay, so now conversion gen has completed, and we can see that it has created conversions files in packages v1 and v2, and also it is giving us some warnings. So these warnings mean that conversion gen could not write conversion for some of the fields, and we need manual conversion for them. For example, while writing conversion from v1 to v3, it could not write the conversion for registration date, and also for the conversion from v3 to v1, it could not write conversion for vaccine details. So let's check out the conversion.go file in v1 package. Okay, so here we can see that there is a function which converts from v1 to v3, and the input is v1 and output is v3. So conversion then is copying the common fields from v3 to v1, but for certain fields which are missing in v3, it requires us to write the manual conversion. So it means conversion then can help us to an extent, but for complex cases we need to write conversions manually ourselves. So now we are going to write them. We will handle the conversions for uncommon fields which could not be converted by conversion gen. We have added two methods here, convert to and convert from. Convert to converts spoke to hub, that is v1 to v3. Convert from converts hub to spoke, that is v3 to v1. Inside these methods, for conversion of common fields, we will reuse the auto-generated methods created by conversion gen. For the conversion of uncommon fields, we will use the annotations that we discussed earlier. Let's go through convert from method. Here we will store the v3 object in annotations of v1, and we will restore the data from these annotations while converting back from v1 to v3. As we can see in convert to method, if there is an annotation present in v1, then we will restore the vaccine details from it, and in this way we preserve the data during conversion. We can refer to more implementation details in the GitHub, and we will link the GitHub at the end of this presentation. Let's go through an example to understand the effect of this conversion.
So now we will rerun our previous example, but this time using conversion. So let's apply our YAML for v3. So we can see we have a v3 object known as registration v3 has been created. Now let's take it in a form of v1 and store it in some file. So if you see in this file, this time we have this annotation field introduced in the v1 version. So we can see annotation is a key value map. Here the key is covin.gov.in/conversion data, and in the value we have the whole v3 object YAML that we applied earlier. So now let's again update it, and let me add symbol in the name. Now I'll apply it again. And we can see that this object has been configured. Now let's try to fetch this object in a form of v3, and we'll see whether we still have the data or we lost it. So we can see now in the spec we have the vaccine details as it is that we applied in our original v3 object. So if you check the YAML, then here also we have the vaccine details like Covaxin, Sputnik. Similarly, here we have. So we can say that using conversion, we preserve the data during the conversions. To access our code, you can refer to this link, and if you want to reach out to us, then you can refer this handlers. Now we are open for any Q&A.